day geometry. We're going back in time to solve algebraic equations, but we're doing so in the setup of a proof. Joey, John, is there?
No.
John, what do you need? Sure? Okay. All right. So when we solved equations in the past, we talked about keeping the equation balanced, using opposite operations, all of that stuff, and that was good enough for algebra, right? But now that we're in geometry, we're running proofs, we have to give reasons why. Why can we add something to both sides? It keeps the equation balanced. True. Okay? But what mathematical property, postulate, definition, theorem do we have here? So it's another kind of a heavy note day. I apologize for that. But these are all key points. They are all things that you could potentially use in a proof. And we're going to start that process today. You're going to write your first proofs today using some of these things. So the addition property says that if A equals B, then A plus C equals B plus C. If A equals B, then A plus C equals B plus C. What is this saying? A lot of variables here. Okay, we're kind of moving to the abstract thinking here. Caleb?
That if each of those are the same, they can be swapped out with C, basically. Like if A and B are the same, then they can be swapped out and they'll still equal the same.
Okay, so A is equal to B and C is equal to itself. Yes, so you can make that argument. In this context, though, just what we have here, not going any further in saying that, but what is this saying, Drew?
If A and B are the same, then we can cancel them out on both sides.
Okay, we didn't do that here, though. Okay, so just what is this saying? Michael?
If A equals B, then A plus C equals B plus C.
That is exactly what it's saying. Okay, excellent job. No, what they're saying here is that, C is the same thing, right? Whatever C is on one side, C is going to be on the other side. So if we've got an equation, okay, such as, let's just plug in, you don't have to write this down, but let's just say that we've got the equation x equals 7, right? Two things are equal to each other. Then if I said x plus 2, that is going to be equal to 7 plus 2, right? If you've got an equation, you can add the same thing to both sides, and it's not going to change the value of the equation. That's the theory behind what we do when we solve an equation using opposite operations, right? We add the same thing to both sides. It keeps the equation balanced. It doesn't change the value. This is the property that tells us we can do that. Okay? Whatever A and B equal doesn't make a difference. We can add the same thing to both sides, and the value is not going to change. Okay? So what do you suppose the subtraction property is? Again, starting with the same thing here. If A equals B, what do you suppose the subtraction property says? Blake?
If A equals B, then A minus C is equal to B minus C.
Exactly. Then A minus C is equal to B minus C. You can subtract the same thing from both sides and the value will stay the same. Again, opposite operations, right? But this is why we're able to do that. Okay? Multiplication property. If A equals B, finish it out. Drake?
A times C equals B times C.
Good. Then A times C will equal B times C. And you can multiply both sides of an equation by the same thing, and it's not going to change the value of it. Division property. This one's got a little bit extra caveat here. Okay? If A equals B and C is unequal to 0, then A divided by C will equal B divided by C. Why do we have to have that little extra piece in there? Caleb?
Because if you divide anything by 0, it just equals 0.
No.
Or sorry, no.
No.
Okay.
Try that again.
Wait. So when you divide anything by 0, it'll equal itself.
No.
Wait, what?
Have you ever asked
Good
Siri
question.
what happens when you divide by 0?
She'd scream.
It goes into this long explanation about like cookies or something, and it ends up saying that you have no friends or something like that. I don't know. No, it is. And if you were to take a calculator and you were to divide something by 0, it comes up with divide by 0 error. Okay, you cannot divide something by 0 because let's think about what division means, right? It's taking an amount and putting it into 2 groups. There will be 3 objects in each of the 2 groups. If you divide by 0, that means you're taking a quantity and you're dividing it into 0 groups. How can you have a quantity in 0 groups? The least number of groups you can have is 1 group, right? Okay, if you don't break it up, you still got the whole thing. So it is mathematically illegal to divide by 0, which is why we have to have this extra caveat here. If A is B, as long as C is in 0, then we're good. Blake, are you going to add on to that?
No.
Okay. All right, question on that one? When we get to some Algebra 2 type stuff, this is going to come into play here. We talked about extraneous solutions in a previous objective. There's other extraneous solutions that come from this property here. So anyway, the substitution property. This one I want you to star. I want you to highlight. I want you to put smiley faces next to it. Anything that's going to help you remember it, because this is a big one. There are certain properties, certain theorems that get used very commonly. Substitution is one of them. So I'm going to write in red. Okay. What's that?
Fancy.
Yes, it stands out, right? If A equals B, then A and B I should put 2 lines for this one, can be substituted for each other in an expression or equation. Okay? If A equals B, then A and B can be substituted for each other in an expression or equation. Yes,
How come
Joey.
it's used so much?
Huh?
The substitution property. How come it's used so much?
Because in geometry, when you're proving angles are congruent to each other or segments are congruent to each other, you can oftentimes prove that 2 pieces are, and there's a third piece that's congruent to one of them. So if A is congruent to B, and you know that B is congruent to C, then A will be congruent to C. Do you remember talking about the transitive property? Did we talk about that in here? Transitive property? That's another one. It's very similar to the substitution property, but that's used very often. Okay, very, very often. The distributive property, where we've used this before, if A, oh no, we don't need the if here. This one is just A times B plus C is equal to AB plus AC, which you're familiar with that one all the way back in pre-algebra probably.
We didn't do
6th grade, which was probably pre-algebra. Okay? All right. So, notes good here? Okay. We're going to walk through, don't go on to the next section yet. We're going to walk through what an algebraic proof looks like, just so you kind of get the process of it. So let's see here. We're going to do another. Oh, is this all it is?
Does this PowerPoint have noise?
Oh, that's pretty good. No, there's no noise in this one, sadly. Okay. So here is an example of solving an equation using an algebraic proof. It's where it's not just showing the work of what you're doing, the opposite operations, but you need to write a reason for each step. Okay? So when you set up your proofs, you start writing your proofs, they should kind of match this setup here. The equation, 2x plus 5 equals 20 minus 3x. We start with the original equation, and the reason is that it's given to us. You cannot write a proof without a given statement. Whoa.
Whoa.
Nice.
Okay,
You gotta work your way.
we're gonna calibrate again.
Nice calibration. Speed run.
Maybe speed running does
That was some good calibration.
Clearly, it wasn't very good calibration last time.
Kind of off on the switch.
Yeah, we'll see what happens. Try this one again. Nope. Okay.
Don't
So-
go so fast.
So the first reason in any proof is what you're told. It's given. Okay. You can't conclude something unless you're given some information to start with here. All right. So the given equation. Our first step here. Nope.
Maybe Mr. Shaw.
All right. Okay. We're adding 3x to both sides. Right. And in algebra, we talked about why we would do that. We would add 3x to move it over. The actual reason for it is what? This is all sorts of. Hold on. We're gonna try. We're gonna. Oh, this is bad. Oh, there we go. Okay, hold on. We're gonna close this. Not save anything because that was horrible. We're gonna reopen it.
Yeah, what this more for?
Someone tell a joke while we're recording here.
I need a
Someone tell a joke.
Okay, Caleb.
Okay. Let's try. Oh, speaking of con, there is con due tonight. Okay. All right, we're gonna give this another try, and I'm not gonna write on the board for this time. Okay. So we have the original equation. That reason is given, as the first reason always is. What property that we just talked about makes doing this legal? Okay, what we did it in algebra is called just opposite operations. We want to move all of our variables to the same side. But what property did we use? And it's one of the ones we just wrote down on your page. Yeah. No. What do we do? We added 3x to both sides. Right? It's the addition property. We added something to both sides of the equation, which on the right side canceled those two terms out. On the left side gives us 5x plus 5. Okay, combining like terms. The reason we can do that is simplify. That one we've talked about before. Okay. The next one, where we subtract 5 from each side to get 5x equals 15. What property defends that step? What property defends subtracting 5 from both sides? It's one of the ones that we just wrote down, and it's got the word subtraction in it.
Oh, subtraction property. Oh, substitution.
No, subtraction property. Okay. And then to get from 5x equals 15 down to x equals 3, we divide it by 5. What property allows us to do that? Caleb? The division property. Okay, the division property. Here's another one. Solve -4 times 11x plus 2 equals 80. Write a reason for each step. We start with the original equation, and what's our reason for that?
Distributive.
No. The original equation, your first reason in any proof that you write, will always given. Okay? Always given. Or it might be marked, right? If it's a diagram, it's marked. Okay, but it's what you're told, right? We go from -4 times 11x plus 2 to -44x minus 8.
Distributive.
What do? Distributive property. Okay? Then we go to -44x equals 88. What do?
Addition property.
Addition property, right? The only difference here is that we've got a -8 here equals 80. We added 8 to both sides to get -44x equals 88 because of the addition property. Okay? And then what did we do to get x equals -2? What was our algebraic step? Drake. That's the geometric reason. What was the algebraic step? We divided each side by -44 because of the division property of equality. Okay, do we have another one here? Is that it? Oh, here we go. Right? Solve 14x plus 3 times 7 minus x equals -1. Write a reason for each step. Notice I took out that middle column of the explanation. Okay, you don't really need that when you write a proof. It's the information and the reason. Our information, start with the original equation. What's our reason? Given, right? Always. Second step, and there are different ways you can go. This order isn't set in stone, right? You know, with algebra, there are certain things you can do before other steps. In this case, this person chose to rewrite this to be 14x plus 21 minus 3x. How'd they get there? They distributed. Shared property. Okay. Their next step says 11x plus 21 equals -1. How'd they go from step 2 to step 3? What did they do? Thomas. They simplified. Combined like terms. Okay. Either one would be fine there. Step 4. 11x equals negative at 22. How'd they get there? Gino.
Subtraction property?
They subtracted what? 21 because of the subtraction property. Okay. And finally, they got down to x equals -2 because of the division property. Right? So it's doing the process you're familiar with, solving an equation with backing up each step. I think that's the last equation I have for you. Now we get to, yeah, these are different angles. Whew, yeah. We'll save that. That'll be a future thing. Okay.
7 Y's of what? Henry VIII? 7 something?
What?
There was a file on your computer. I swear it was called the 7 Wives of like Henry the something.
Do I dare look?
Yes. Yes, 7 Wives of
Oh, these are all logic puzzles. These are like you did with the tricky touring. Well, you can. I'm showing you the file. You can look at it. It's a set of clues, and it's a. Yeah, I am actually. I've got nothing to hide in my flash drive. Okay. So you can notice how much space I left you to work here. That's not by accident. Proofs are kind of a lengthy thing. But I'm asking you to solve the equation 4 plus 8x equals 10x minus 10. How are you going to start this? You're going to write the statement. These are your headings. Statements and reason. Okay? Statements and reason. Your first statement should be what you know. What do we know? We know that 4 plus 8x equals 10x minus 10. Okay? And how do we know that?
Given.
It was given to us. Right? Given. Okay? Now, where do you want to go from here? Like I said, I mean, there are different ways to solve for x. How do you want to start? Let's just all take this and I'll do it the same way, but how do you want to start? Peter.
Subtract 8x.
Subtract what, sorry?
8x.
Okay, so Peter wants to move the 8x over to the other side, which means that our next step, our equation is going to look like this. 4 equals 2x minus 10. Notice we're not showing the work. Right? We say what we're doing. We write what we get as a result. But notice I didn't write in here minus 8x minus 8x. Okay, that's the algebraic way, showing the work. The geometric way is to just do it and then explain why you were able to. What property allows us to do that?
Subtraction.
Subtraction property. Okay. Yeah.
14 equals 2x.
Sure. Our next step would be 14 equals 2x. Why are we able to say that? What do we do? James. We add a 10, so what property says that that is legal? Addition property. Okay. And finally, Mackie?
7 equals x.
Because?
Division property.
Division property. You just wrote your first proof.
Yeah.
Wow. Good job. Right?
Yeah,
That's all there is to it.
we should get another chance.
I put in my everything.
And then it's gonna be.
But hopefully, you're starting to see and understand my warning of knowing these properties and knowing these theorems and everything that we're going to be talking about here, because you might be able to solve the equation, and then in algebra that's okay, right? You're algebraically able to solve for x, but geometrically and explaining why you did each step, if you don't know what these names are, if you don't know what you're doing, then there's going to be a problem. Okay, so we're starting off with something that you know, something you're familiar with, right? But if you flip over to PO16, then you'll see things kind of get into the
Go
unfamiliar.
downhill?
We go into the unknown.
No.
Is that a Frozen song?
It is. All right, next one. We've got our statements. And we have our reason. Okay. Number 1, 7 minus 12 times n minus 4 equals negative 18n plus 37. I have a habit, you'll see this, that I never leave myself enough space for the statement. So I apologize for that, but this is the longest that the equation is going to look here. So 7 minus 12 times n minus 4 equals negative 18n plus 37. Why do we know that? How do we know that? It's given to us. Okay. And where do you want to go next? Where's your heart calling you here? Michael?
I want to distribute.
You want to distribute. Let's do it. So that'll give us 7 minus 12n plus 48. I lied. It's not the longest equation yet. It's the same length. Plus 48, actually. Negative 12 times a negative 4. Okay. Plus 48. And the reason why we can do that is because of the distributive property. Okay. Step 3. What do you want to do? What do you want to do? Drake?
Move the 12 into the other side.
Sure. So we can move the 12 over to the right side. So we're left with 7 plus 48 on the left, and then a negative 6n plus 37 on the right. And we're able to do that because addition property. Okay. And we're not showing the work here, but we're adding 12 in both sides. What next? Peter?
Add 7 and 48.
To get what?
55.
55 equals negative 6n plus 37. And that is because we are simplifying or combining like terms. You can put either one. Simplifying or combining like terms. Now what? What would our next step of this equation look like? Joe?
Subtract 37 from the left side.
Okay, so that leaves us with 18 equals negative 6n because of the subtraction property. And then divide both sides by negative 6. So we get negative 3 equals n because of the division property. Cool, huh?
Not really.
It's not bad.
It's not extra steps, it's defending each step. It's defending each step. Using a mathematical
Who's
property.
going to be
here.
challenging
Can
us?
we just accept
Huh?
Who's going to be challenging us?
On this stuff?
Yeah.
I will.
Why can't you just plug minus 3n into the statement and say,
The old guess and check method. Yeah. So this is where a substitution would actually come into play. If I had you check this, then you go back to the original equation and substitute negative 3 in for n. So those of you that do check your work and check your values, what you're doing is the substitution property. Because negative 3 is equal to n, you can substitute negative 3 in for n in the equation. That would be the substitution property. Okay? All right, your assignment for tomorrow
it's nothing?
is
Nothing.
How many of these should I have you do? That's really the question.
One.
One?
Like five. Three.
One?
One.
How about page 108?
Hey, what? Yeah, the Vikings. Three.
The Vikings play? That's true, they do.
This is you should make.
Where's
Yeah,
my-
the Packers
where's my
play.
red-
Go Pack, go. The Packers
Where-
and the Bears.
I'm a Packers fan, so I should get less questions.
Yeah.
Where's
For
my red
Packers
marker?
fans, you get less questions.
Please come to the office. Genevieve Drew.
Where's no? Hey, where's my red marker? Anyone see me put it down anywhere?
Oh yeah, I see it.
Where is it?
It's right here. On the desk.
Oh, in my face mask. That's clever. I'll take 2 questions off.
Let's
That
go.
helps.
Let's go, Joe.
All right, page 108. I am going to. I was going to give you 3 and 4, which I'm going to give you anyway, because those are just kind of fill in the blank stuff. And then on page 109, it carries over. I'd like you to do 6.
And only 6.
No.
6. Oh my God.
Wait, you're gonna make it worse.
7.
6
And
8
Oh.
and
9. 36.
what number is Adam Thielen? Is he 18?
19.
But he's hurt.
He is hurt.
And JJ's better. 18.
18.
He's one
Justin
better.
Jefferson.
I'll give you a Kirk Cousins. I'll
Tom
give
Brady,
you
number 12.
And we'll go with the GOAT. All right. Kirk Cousins and the GOAT.
Aaron Rodgers.
I meant Brady, but it does 12 is
Vikings
Rodgers.
So then who did you take off?
Tom Brady is the best.
He's actually 7 now, isn't he? Brady
Tom
is
Brady.
Brady's
That's
12.
Fournette.
What?
That's Lamar Jackson.
Anyway, 4
That's
of them
Joe
to do.
Mauer.
4 of them to do. 3, 4, 8, 12. Kirk Cousins, Tom Brady, feel free to sponsor any of my videos.
Who did you take off?
I'll give you 13. All right, folks, that's it, man.
Oh, no.